RCR Wireless News. I'm Sean Kinney, and welcome to this latest episode in our Cloud RAN Deep Dive series. And I'll make this note right off the top here. While the broad focus of this series is the radio access network, it's really impossible to thoroughly cover that without also looking at the technology trends that are reshaping the transport domain. So it's a pleasure to welcome with Ericsson Jari Augustin to talk transport. And I guess a little more context here, this long move in the RAN right now is a march towards deploying radio functions in distributed cloud environments, as well as this transition in the core to cloud native and 5G standalone, which really does have major implications for how services are delivered. So Jari, kick us off here by helping us understand how all of this impacts the way operators are thinking about and investing in their transport networks.
Thanks, Sean, and thank you for having me here. Really good and interesting question. It has been a hot topic in industry during the past few years. So mobile networks evolve with new system generations bringing higher speeds and new service capabilities. And with this evolution, 5G mobile backhaul and fronthaul play an increasing role with new challenges in matching new 5G system capabilities. Looking back, GSM, Release 99. So mobile transport was more about providing the coverage, providing the connectivity from the radios to the controller. The transport technology was dominantly based on TDM. It had inbuilt SLA capabilities, synchronization too. So the mobile transport was pretty straightforward in those days. However, mobile broadband, HSPA, changed that. So peak capacity is increasing significantly, and it was really important for the service providers to optimize the transport costs. And that was the time when IP/MPLS pseudo wires were introduced to the backhauling for the first time. When looking at the 5G transport networks today, so those have become really complex in terms of network architectures and use protocols. Those are quite different when compared to the situation 10 to 15 years ago. Also with 5G, higher peak rates surely were an important enhancement, as was the case with 4G. However, 5G doesn't only support traditional mobile broadband, but also new industrial and enterprise use cases too. And with this evolution, with these new use cases, 5G mobile backhaul and fronthaul play an increasing role. However, as mentioned, networks do evolve, and there are many drivers for that. Capacities keep increasing, densification, the focus on OpEx reductions and sustainability, and these are definitely important drivers. But so are the changes with the radio access network architectures too, such as centralized RAN and Cloud RAN. And Cloud RAN will be one of the inflection points for transport, and is also one of the key drivers for switch fronthaul too, which is a new area and opens up opportunities for new type of network implementation. So I would say that the importance of transport will further increase in the Cloud RAN and switch fronthaul era. So many say that transport will be inherently part of the Cloud RAN solution, where the transport infra needs to connect the distributed Cloud RAN elements and the existing basebands. And this increases the complexity even further, including how to manage latency, how to manage synchronization accurately. And when it comes to the network management, radio cloud with connectivity needs within and through the data center to the other sites and towards the transport network, this requires orchestration across transport and cloud infra. So Cloud RAN will increase complexity of the existing networks, and when we add complexity network domains which are really critical and time sensitive, then automation is a must. So making the transport network automated to speed up the service creation and have automation capabilities to maximize the reliability and availability are almost mandatory for the service providers.
So you referenced the need for increasing degrees of automation, and that's kind of a line that goes through all these network domains, core, transport, and radio. And it's really one of the drivers of this push to cloud, making sense of increasing complexity and then automating what can be automated. So can you break out for us these vectors of complexity that Ericsson is tracking?
Sure, it's not a secret that automation is increasing in importance in the telecommunications industry nowadays, in all not network domains. Cloud RAN is one thing, but it is an important question even in the existing deployments too, and for valid reasons. So many surveys show that the great majority of the network changes are still performed manually. And at the same time, the number of type of devices that require network connection is growing exponentially. Capacities are increasing, multi-generation mobile networks, multi-vendor implementation, virtualization. All this means the networks are getting complex and deployments are getting massive. So I believe, the main components of complexity include increasing capacity demands, and at the same time, the number of connected devices is growing rapidly too. We have multi-generation mobile network management requirements, and this leads to a higher number of network connections with really strict quality key performance indicators. We have to support multi-vendor implementations, and everything needs to be future-proof for evolving use cases such as network slicing.
All right, now I wanted to talk a little bit about the product piece. So, how does the Ericsson Transport Automation Controller address the complexity we just talked about, specifically around high value items that directly hit your operating budget? Things like root cause analysis, reducing truck rolls, reducing site visits, cutting back configuration errors, things like that.
We could say that it's humanly impossible to manage the complexity in all these network changes at scale with quality and speed. And it is therefore not a surprise that networking leaders often cite network automation as the top three strategic priority in their initiatives. So while automation is seen critical to improve OPEX, the level of automation is still relatively low. And one of the main issues preventing CSPs to automate their network is poor network visibility. CSPs are still in the dark when it comes to understanding the network state. When you do not see, it's hard to know what to do. And CSPs are looking ways how to maximize the operational energy efficiency. So typical questions are how to reduce site visits, how to minimize the problem isolation times, how to identify root causes quickly and accurately. Is it possible to reduce transport network energy costs? How to reduce the number of configuration errors, which is still prime source of many issues. But at the same time, CSPs are looking, how the performance of the network can be improved, how the capacity utilization can be optimized, how to minimize the latency, packet drops, jitter, how to maximize the user experience. And these are the typical questions that CSPs are struggling with, and our new Ericsson Transport Automation Controller will resolve many of these challenges. So, all right. So, how does Ericsson, Transport Automation Controller resolve these challenges? It has three main functions. It observes, it analyzes, and it acts. And the observation is one of the key values, providing real-time visibility of the transport network with intuitive UI, interactive maps, and dashboards. So single pane of glass of the transport network. And today, the great majority networking issues are still invisible to the service providers. End customers might complain, but CSPs are really in the dark. And that's something we want to fix. Overall, we want to provide the best possible network visibility and observability to our customers. The idea that service providers can focus on fixing the issues, not troubleshooting. It will find the needle from the haystack, and that this reduces the problem isolation times significantly. Then our transport automation controller can analyze. So we will identify and show the root causes for network issues. We want to provide actionable insights of the network, not just raw data, but insights why certain things and issues are happening. What is the root cause? Do these issues require actions from the CSPs, or will some of the performance degradations go away without any site visits? So we don't only show where or when something has happened, but also why. And later with AI and ML, predict when certain issues are to happen. And this is a huge benefit for the service providers since the number of site visits can be significantly reduced. And last, our controller can also act. So when the system has real-time understanding of the network state, what happens and where, enables our controller to automate and control network operations. Closed loop functionalities like automated service provisioning, automated AI ML powered traffic steering, and so on. And this doesn't only improve time to market, but also reduces human errors and misconfigurations, which certainly is still some of the prime reason for networking issues.
We talked about cloud as one of these major trends that's touching every part of the network. Another one is sustainability, and that's reducing power consumption and gaining system level energy efficiencies. So maybe tell us a little bit about what levers operators have available to them that will help them address their sustainability goals. Really, how is Ericsson helping them cut power consumption and costs associated with the transport network?
All right, so I will now focus mainly how our transport controller and SDN can help CSPs to improve the energy efficiency. Obviously, the next generation hardware, new network element capabilities and features are a topic of its own and will continuously improve the sustainability figures. But transport management, SDN, AI, ML can help CSPs to reduce the energy consumption also. So the first method to do that is super simple. So when you can optimize the performance and available capacity of the transport network, then you at least can postpone some of the network element upgrades. Really use the available capacity as well as possible. And this obviously one simple way how to reduce not only the capex but energy consumption also. Another example is related to AI and ML capabilities. I already mentioned earlier that our transport controller can act. So when the system has real-time understanding of the network state, what happens and where, enables our controller to automate and control network operations. And when it comes to energy efficiency, our controller can do automatic and AI ML powered or like traffic prediction based activation of deep sleep for certain microwave carriers. And we can dynamically maintain the optimal window for the radio deep sleep. And this is kind of really significant saving for the CSP. And there are obviously other ways how to reduce the energy costs, especially for the microwaves, so such as traffic-aware power save. And last, kind of repeating myself, observability and analytics will enable CSPs to focus on fixing the network, not troubleshooting. So run the networks proactively, not reacting to different issues. So optimize the available capacity. And this doesn't only improve the network availability, but also reduces the OPEX and CAPEX.
Jari, I also wanted to talk a little bit in more detail about artificial intelligence and how it fits in here. We are thinking about and talking about achieving this new level of visibility, of observability into the network, then using data analysis to turn that into an action, and then increasingly automating that process. But just how does AI fit in?
Ericsson has dedicated more than a decade to incorporate AI and ML into microwave networks for use cases such as advanced microwave analytics and energy optimization. And now we want to broaden the application of AI and ML to additional transport domains and automate IP and optical networks also. And we do have a long expertise and understanding of the mobile networks, traffic models, traffic patterns, 40 plus years of experience on building and managing the microwave networks. And this is a really key unique capability for us to build accurate AI and ML models also. Another key fundamental for us is to collect lots of network data, performance management data, alarms, and so on. So really accurate and granular network data. And this is also one of the key functions, how to build not only better analytics capabilities, but also more accurate AI ML models too. So one example of the AI and ML is advanced analytics for microwaves. So the tool highlights the links automatically for the whole network where RF availability has been hindered when the events on the radio like wind, rain, multipath, intermittent obstruction, and so on have been so severe that have even caused RF unavailability and provides information about the root cause. Basically, the tool says whether the CSP should send someone to the site. The tool says, like CSP, whether they should act. And that this is the case if the root cause of the issue is wind. It makes sense to check if the installation of the radio has been done properly. But the problem sometimes can go away. This is the case with rain or some of the other performance degradation events too. And overall, this is a really significant saving. It improves the efficiency a lot. And we are seeing really significant opportunities in this intelligent AI ML powered RCA area, not only with microwaves but also with IP to speed up the root cause analysis for different kinds of networking issues. Another good example is the traffic prediction. So that is an area we have studied a lot too. So one good example is the one I mentioned earlier already, is related to the energy efficiency. So when you understand like the traffic patterns, so then the controller can dynamically define the optimum time to activate functions such as radio deep sleep. It's a significant saving. And this kind of traffic prediction can be used in many IP cases too, like related to traffic engineering. And third really good use case of AI and ML is about preventive maintenance. So when certain hardware is expected to become faulty. And this is another area we have studied a lot. So the hardware can be switched to a new one while it's still operational. And this way we can kind of improve the uptime of the network a lot. So overall, the list of opportunities where to use AI and ML is almost endless. So and helps to manage the networks more dynamically and proactively.
So maybe as we end, we can provide a bit of summarization. If I'm hearing you right, it's clear that transport's going to be a key focus area as operators look to better monetize their networks to increase performance and to deliver differentiated experience. They can also, at the same time, cut down on their OPEX, chip away at their net zero targets, and really start to make progress on their larger automation strategies. But bottom line here, what are the benefits operators can realize with a strong transport strategy, and why is Ericsson the right partner?
I would summarize this in the following way. And I think there are like three key priorities. Really strong transport strategy will help the CSPs to optimize the network performance. By eliminating issues fast and automatically, service providers can maximize the capacity of the network, which will result in happier end users and less churn. This will minimize the complexity and maximize the efficiency. So like reducing manual work through SDN automation and saving time in fixing issues with near real-time root cause analysis. And also from the energy perspective, we help increase efficiency through AI-driven traffic prediction and fully automated optimization. And finally, it will help them to reduce cost by having less site visits and not having to return equipment that works for no reason. And this will also enable CSPs to be future ready for evolving use cases such as packet front haul and network slicing.
Jari, I really appreciate you taking the time to join the Cloud RAN Deep Dive series and give us a detailed understanding of how transport fits into all of this. So thank you.
And thanks, Sean, again for having me here, and thanks for the really interesting discussion.